In this video, I'm going to continue talking about the an introduction to the civil structures chapter of the HSC Engineering Studies course. So I'm going to go through this. I probably should have asked for the student for permission to put this on, but how we're running with it. So this is his assignment. So he has got a title page, which is good. He's got page numbers. He's got an abstract. He's got a table of contents. I think that could have been a bit cleaner, but can't take any marks off because he's done it. He's got a main section with an introduction, and then he's gone into design solutions. Now, he really should have 3 design solutions. I guess this is 1, 2, and 3. I probably would rather he drawn them, but I guess I can live with that. Okay, then what he's done is he said, this is the idea that I've chosen and why I've chosen it. Then he's gone and done a formal final design of his idea. So he had to compare, when they did it, they had to compare 2 designs. So you did one and your friend did the other and you compared your 2 designs. What they did is they compared I'm just going to see if I can zoom out here. They compared, does that rotate? Excellent. Okay, they compared this shape to this shape. Can you see the difference? That member there has been strengthened because they had determined, using calculations, that they had determined that that was likely to be the area that was most likely to fail. So they had strengthened that location. Now, then what they did, is, I have to return back to the other way. Okay, so then what they did is, I want to zoom in. They said who was going to do what job, and then they said how it went, how well this was managed, how time was managed, how quality was managed. So they said how they ensured that things were done on time, how they ensured that things were done properly. Okay, then they talked about the documentation of the testing process. So they had materials, equipment, they had a method. So they've shown an example here, the results, the point of failure, where it's failed. They had load at failure. And then they've done their analysis. So they've calculated their load to weight ratio, and they've found that their ratio is about the same in both cases. It shouldn't be load to weight is correct. Okay, axial stress in the critical members. So what they've done is they've found out which section was the weakest section, and they've figured out the stress in that section. In the strengthened truss and in the unstrengthened truss, they figured out the maximum stress that they found. They compared that to if they just used a beam. So we tested a beam. Everyone in class tested a beam, and we compared that as our baseline to say, was our stress? Did we have more stress or less stress? Was it more efficient or less efficient? Okay. Then they have the full calculations here. So they've taken a photo of all their calculations and included those. And they've got a conclusion saying neither of the trusses failed as expected. Why? And then they explain what their belief is. They talked about the the downsides of their truss, the advantages and disadvantages. They talked about the results from the beam test shown in the analysis. Proving the benefit of trusses over simple beams. So they were able to say that the truss was more effective than using just a beam. So that's why we use trusses. Okay, so that's a general overview of what you're going to do. Then they had their references, and the references are referenced properly. Okay, so that's an example there. I am just going to close that tab. Now, like I mentioned, the big thing is I wasn't asking for dimensioning to Australian standards when I did this assignment. I'm now going to say that that is something really important. Now, part of this topic, I've mentioned that there's a... Okay, so the important thing that we're going to have to do in the HSC, and if I go back to my examples, we can see several examples of HSC questions that rely on threaded sections. It's really important that we understand the rules for threaded sections. So I've got, going to this here. Now that is from the Australian Standard. I have a link on the group chat on the Australian Standards. This is the Australian Standards. You can see it's 240 pages, right? Now, what I have tried to do to make this a little bit more student-friendly is I have gone through the pages that I think are relevant. So, for instance, this page here is relevant. Now, do you need to know this page? Probably not, and the reason why you probably don't need to know it is because in the Copeland book, which I must have closed, in the Copeland book, they provide the most important things that you need to learn for the HSC. Now, my attitude is I personally still can't remember these off the top of my head, right? And I would suggest to you that what you need to do is you need to learn them basically the day before the exam, which, as I recall, this happens to be today for my current Year 12s. So they should be spending time. There's only 2 things that I say that for, and this is one of them. Okay, so I've shown you the actual Australian standard. I'm going to show you a couple of other things that we're going to highlight for drawing standards. So for dimensioning, the big picture that you should be doing is your dimensioning should look like this. Now, I've said the pages that are relevant, right? So you can go and look for yourself. There's also a Victorian Education Department, so the VCE document, which I've also uploaded. In page 20, they talk about this. I'll go to that in a second. But in the meantime, so page 95 and to page 190, so it's quite a few pages on dimensioning. What are the things we need to look at? Well, there's the ways that we dimension circles. So we've got 3 different ways. We can have a diameter 10, or we've got 40 diameter, so we can write inside, we can draw an arrow to the outside, or we can draw an arrow that points to the inside or 2 edges, and we use extender lines. Ideally, we like to use extended lines at steep angles and then flatten out. That makes it really easy for the person looking to see. It's also worth mentioning that dimensioning lines should be thin and dark, whereas the rest should be thick and dark. The dimensions are always written to the left of the line or above the line. Now, there's a way I remember, I think of it being like the number 4, and the number 4 points up and to the left. If that helps you to remember, great. If it doesn't, just remember like Beyonce. The numbers are always written to the left. See how that 100 is written to the left of the line? That 70 is written to the left of the line. The 100 is written above, the 60 is written above. Now, one more way of writing dimensions there is circles, is to write them like that. We talk about center lines. Center lines should always be thin and dark. It's hard to do that with a whiteboard marker. Radiuses, radii, they should be done. They should still have a center line, and we point to the edge of the radius. That's a general idea of what we want to do. There are some things. If we have 2 sets of dimensions, we want to have the smaller one inside the bigger one. There's also requirements for how we do the arrowhead. The arrowhead should be 3 millimeters long and 1 millimeter away from the line. And that we should have a 2 millimeter gap between the object we're drawing and the thing we're dimensioning, and that 2 millimeter gap should also extend past our dimension arrow. Okay, so I'm going to pause for a second. So here in Files, I have the AS1100 and the VCE document. And when we go to the VCE document, I think they said it was on page 20, I have the standards for dimensioning. Are we page 20? No, not yet. Page 20? Nah, maybe it started at page 20. Here we go. So there's the dimensioning requirements. There's quite a few things here. It's a good document and definitely something you can use. Okay, one last thing that's worth talking about is sectioning. So when we section, there's a few things requirements. When we're sectioning through circles, we have a requirement. So the page 89 of the AS1100 says, look, you can section these thick sections, these what we call webs, but you shouldn't, right? So as far as the HSC is concerned, don't do it like ever, right? There have been questions. So for instance, the 2006-2019 question asked basically that. Okay. So I'm just looking. I'm going to pause. Okay. So with the designs, so there's this guy called GarrettsBridges.com, and he has some really good stuff. So he talks about the different kinds where bridge, beam, truss, arch, cantilever, suspension, cable stay. We talked about all that. But then he talks about the different kinds of trusses that you can make. So the Howe truss, the Pratt truss, the Warren truss, and the K truss is somewhere here as well. And what he's done is he's also got a example of how those loads will be distributed for those different kinds of trusses. Now he used a software called the Johns Hopkins Truss Designer, or Truss Simulator. Now the problem is that it now has changed. It didn't work for a while, and now they've updated it for a new site. Now I think it's more accurate than it used to be, but I'm not going to build one now to demonstrate. But you can see the idea of what we want to do is find the critical member. So in this case, the critical member is this 139. We're putting a test load of 100. The critical member is this one, 139. It's going to be whatever load we put on here, the force inside here is going to be 130% of that. That's for a Warren truss. For a Pratt truss, what do we got? If we put 100, whatever load we put on, this member here, the critical member, will be 100% of that load, of the load condition. I won't go through any others, but you get the idea. The K truss should have one as well, actually. The K truss is only 67%. So the critical member there is going to be 67% of the load that we apply to the truss. The last thing I'm going to talk about in this video, and to finish up for today, is that the next thing that we're going to look at before we start worrying about beams, moments, we've already covered moments a little bit, before we start worrying about that, we're going to look at something called reactions. Now, when we talk about reactions, there's 3 different kinds of ways that we can stick a bridge and hold it in place. So the first way we could do it is we could just have the bridge on roller skates. On either side, it's on some sort of wheel, and the bridge is just allowed to move left and right. But so that we don't have the bridge just sliding off into the water, we usually want to have one side that is fixed into place, or pinned into place. And what that means is it allows it to bend up and down, but it needs to be fixed. It needs to be located in one location. Now, the other way we could do is we could actually build the bridge into the brickwork. In which case, if it can't bend anymore, it can't twist or turn, it's called a fixed location. Now, I'm going to talk about that. I'm going to show you a couple of pictures. Okay, so in this picture here, we can see this is an example of the rollers that bridges sit on. And here's an example of a pin that a bridge is sitting on. Now, what we're going to learn about is, so we're going to... okay, this is the first picture I ever made for engineering studies, to try and help you to remember the difference between these different kinds of pins. Now, these different kinds of reactions. So if we have a roller can only apply a reaction force in one direction, right? So it's a simple, it only has, you can think of her as only liking one thing, right? She only likes one direction, right? So she likes perpendicular forces, that's all she likes. Pins, on the other hand, they're a little bit more adventurous, and they like perpendicular forces and parallel forces, right? So it means that they can also provide a reaction to stop the bridge from rolling into the ocean. Whereas on the other hand, fixed reactions, well, they're really adventurous. They're happy to take not only perpendicular forces, parallel forces, but they also can take moments, and the other ones can't take moments. Now, fixed reactions, that's a little bit too full on for our course. We don't really talk about that, with one exception, right? We're only going to focus, every bridge that we do will have one roller and one pin. So the starting point is that we are always going to try and find Ricky, the roller, first. That's always what we're going to do. That's going to be the starting point, our first step on our journey of moments and our journey of trusses, is that we're going to start by always finding the roller first.